For this lesson, we're going to pick a couple organisms and the sun to place into our pyramid. So I'm going to pick the hawk, the sun, a baby raccoon, a toad, some insects, and the reed. So when we're talking about energy levels, what we're looking at is who makes the most energy and where does the energy come from. Now I know that we're going to talk about photosynthesis later, but where does the majority of our energy come from? Well, it comes from the sun. So you go ahead and put that in the bottom of your pyramid. Well, what does the sun actually do for us? Well, our reeds are going to use that in order to produce their own food. So I'm going to put the reeds in here. But who's going to eat our reeds? Well, that's going to be our insects. And then who's going to eat our insects? Our toad. Who's going to eat our toad? That's right, our juicy baby raccoon. Now, who's going to eat our baby raccoon? Hopefully you've guessed it, and it's the only one that we have left. It's our hawk. I'm sure you guys are wondering, what does this even matter? I understand who eats who. Well, with energy levels and energy transfer, it's all about how much energy is getting transferred from whom to whom. Now we know that our sun makes energy. So I'm going to put a big sun here. But our reeds are the first people to use it. We call those our producers because they produce their own food. Now who's going to be the first one to eat our producer? That's going to be our insects, and we call that a primary consumer. So what comes after primary? Secondary. Our toad is going to be the second person or the second receiver of that originally produced energy. So we're going to put secondary consumer. Now, hopefully you guessed it from here, our baby raccoon is going to be our tertiary consumer. And our hawk is going to be our quaternary consumer. The question that we're faced with now is how much energy from our sun is going to be given to our reeds, how much is going to be given to our insects, our toads, our baby raccoon, and then our last one, our hawk. The energy transfer between each level is only 10% of the organism's initial intake. So let's see what 10% of a number looks like. If we start off with 1,000, our next organism, or the organism that eats us, is only going to get about 10% of what that organism's originally energy intake was worth. So 10% of 1,000 would be 100. And 10% of 100 would be 10%. And 10% of 10% would be 1. And from 1%, we can say 10% of that would be about 0.1%. Now what's after 0.1%? 0.01%. Now let's see what that looks like inside of our pyramid. Okay, if we start off with the sun being 10%, or 1,000%, sorry, go ahead and place in what the other organisms' intakes would be. Our reeds would get 100%. Our insects would get 10% of that. Our toad would get 1%. Our juicy raccoon would only get about 0.1%. And our hawk is going to get 0.01%. And the percentages are talking about how much our hawk is going to get of the sun's original energy. But look how far the energy has to go in order to get through to the hawk. When we look at our pyramid and we look at the amount of energy that is transferred, one thing that we can infer or notice is that as we get higher up on our pyramid, our energy levels or our energy transfer gets lower. Right? If we started off with 1,000, we're only ending up with 0.1% in our baby raccoon and only 0.01% in our hawk. So the higher that we get up on the food chain, the lower amount of energy that's being transferred. Now we're going to talk about bioaccumulation. But before we define what it is, let's look at the word and see if we can break it down into something that we know. What does bio mean? We know that bio means life. And when something accumulates, we know that it builds up over time. Bioaccumulation refers to the buildup of substances like pesticides in an organism. So to show this, we're going to use our other pyramid that you have on your sheet. And I'm going to put the same organisms that we did before. So let's start off with the sun. Then we had our reeds, our insects, our toads, our raccoon, and then our hawk. So pesticides are something that farmers since pesticides are meant to be sprayed on crops to deter pests from eating them, I'm going to go ahead and put my pesticide right here. And bad, right? Pesticides are bad. Now, who's going to be eating our reeds covered in dangerous pesticide? Our insects. But insects aren't just going to eat one of them. They're going to eat multiple, which means they're going to be building up pesticides inside of their system. So our insects are also going to be getting sick. But it's not going to stop there. We are building up over time. We're building up in our food chain. Our toads aren't just going to eat one insect. They're going to eat multiple, which means that they're going to be getting an insane dosage of our pesticide as well. And they're going to be sad. They're sad also. And our baby raccoon probably won't survive with just eating one toad. They're going to be eating multiple, So once again, they're building up pesticide as well. But let's put some numbers to this in case you guys aren't quite sure how to visualize this. If you're a number person, this might help. So we get our 1 dose of pesticide. So maybe we'll say that this is 10. But what's double our 10? We're going to say this is 2 times the amount. That's 100. And now we're going to do 3 times the amount. And we're going to say that's going to be 1,000. And then so on. And so forth. So what do we notice, or what can we infer about the trend of pesticides? Well, the higher that we get up in our food chain, the more pesticide is going to reside at the top. It's going to accumulate more. There's going to be more pesticides towards the top. That's our building up over time.